and stay-at-home orders that discourage people from leaving their premises to walk
Yeah.
around. Not good for health.
Oh, my kids are using it every day. I said, "Come on, we got to get out." Like, Mom, we have to shelter in place, so we can't leave the basement.
Uh,
It's ridiculous.
Professor Shane O'Mara, writing in the Wall Street Journal over the weekend, he's a professor of experimental brain research at Trinity College in Dublin. Recent experiments show that as few as 3 or 4 days of inactivity reduces muscle mass in the legs, starting to replace muscle with fat. This isn't much of a problem when you're 30, but it is when you're 60, needing assistance to stand up from your chair. The cure: get up, walk about, and fight the frailty that can come with aging. He notes that we don't realize what we don't realize is that walking can be a kind of behavioral preventative against depression, benefiting us on many levels, physical and psychological. Walking helps to produce protein molecules in muscle and the brain that help repair wear and tear. These muscles and brain molecules have been intensively studied in recent years for their health effects. We're discovering they act almost as a kind of fertilizer that assists in the growth of cells and regulation of metabolism. They also reduce certain types of inflammation.
And this is why you walk when you play golf, right?
It is also so I can live down to the Mark Twain characterization that it's a good walk spoiled, which it definitely was yesterday in Munster, Indiana.
Oh,
Terrible. I almost left the course walking
really?
without my golf clubs.
Is that bad, Dan?
It was bad.
Oh, all right.
Speaking, and by the way, we mentioned how hospitals, the great irony that all the praise that's being heaped on doctors and nurses by central planners is being undermined by their policies as hospitals are cutting staff, furloughing staff, cutting salaries because of the economics they're now faced with under the strictures of federal and state government. Same thing happening in the fitness industry, like any other business right now. 24-hour fitness, 400 clubs around the country
Ooh.
shut down, and they're weighing options, including a bankruptcy that could come in as soon as the next few months, according to CNBC's reporting.
We
Okay.
need church and gyms now more than ever.
For more on the topic of biology in general, we're talking about biology of walking. How about the biology of the virus itself, what we know and what we don't know, as we're still learning? That seems clear. We're pleased to be joined by Professor Benjamin Neuman. He's the head of the biology department at Texas A&M University, and he has written on the topic at theconversation.com. Professor Neuman, thanks for joining us. Appreciate it.
Good morning, Dan. Good morning, Amy.
Good
How can I
morning.
help?
Good morning. So, we everything is to try to provide a frame of reference. Is it like the flu? Is it like SARS? Is it like MERS? Tell us what we do know about COVID-19 and what we're still trying to figure out.
Yeah, okay. We are learning a lot about the virus itself. The virus actually is SARS, and it's SARS coronavirus 2, and it's genetically got all the same parts as SARS. Goes into the same cells, seems to do pretty much the same thing. We had a couple really interesting developments, and I think these were just released as preprints on Friday. So they're going through the scientific review process. They're not quite all the way there, but I looked at these things, and I would be surprised if a hair on their head changes. What these two studies show is part of the reason why it looks like older people tend to get more severe disease than younger people. And the reason is just sloppy expression. So down in our lungs, there are all these different kinds of cells. And when we're young, we're really tightly controlling which cells are making the two proteins that are most important for the virus getting in. And as we get older, that control just slips a little bit, as I guess it does in other ways too, and we start expressing those proteins in more cells. And so you get more cells infected, more disease, harder to clean out. And that seems to be a pretty decent explanation for the dependence of age on disease.
But what if you're a healthy 78-year-old? Of course, I'm talking about my mother who works out, never smoked, and literally works out 5 to 6 times a week, or she used to before being sheltered in place. I mean, does that do anything if you leave a healthy lifestyle and you're older? Is there some hope for you?
Yeah, no, there's hope for everybody. We've seen all these people who are over 100 recovering and, getting cheers and claps as they go out of the hospital, and that's wonderful. But the thing is, you can't really exercise your gene expression pattern, or rather, I haven't read how to do that effectively, I would say. This is something that's going to be controlled from inside your cells. There are going to be genetic components, and a lot of it is going to be something that you don't really know how it's going to go until you actually would get the virus. And so, no, it remains fairly unpredictable, which is, I don't know, in some ways good. It means that it's never a death sentence if you get this thing. But in other ways, it's just, there will be severe cases in young people occasionally, and there will be older people that actually do all right.
Again, in terms of the areas we don't know with respect to the virus, one of the questions is about, well, to put it, to borrow from Shakespeare, UV or not to UV? That is the question. I'm ABC News. Ultraviolet light may help fight the spread of novel coronavirus. LA Times, how UV light may protect us from the coronavirus. A study out of France, coronavirus can survive prolonged exposure to high temperatures. So those are competing conclusions about UV light. What are we? Do we have any real handle on the impact of weather on the virus?
Yeah, so it's not so much weather, but UV light absolutely knocks out viruses. So what it does is the virus is actually just a mechanical thing. It's not really alive. It's just a little machine with a bunch of working parts. And anything that you can do, like a little bit of soap or a little bit of one of those hand sanitizers that kind of scrambles those parts around, just moves them to slightly different places, will absolutely wreck this virus. Now, UV works in a different way. So this is going to attack the actual virus genome, so the little piece of RNA that's inside this virus. And what it does is just link together some of the bases. It just makes little tiny knots, basically ties the virus in knots. And once that happens, if you get even a single one of those in the part that the virus needs to read, that virus is dead. It cannot be copied. It cannot start an infection. So UV is super effective against the virus. And, we've known about this for a long time. It's a good thing to use. Heat is, it depends on what you mean by heat. So in the laboratory, if you heat up this virus to about 50 degrees Celsius, which would be well over 100 degrees Fahrenheit, there are a couple proteins that fall apart. They basically pop like popcorn. And once that happens, again, the machine just doesn't work anymore. But temperatures like normal weather temperatures that we would experience in Chicago or even in Texas are not going to knock out this virus. And the most important thing is that the weather inside of a human body is always 98.6 and sunny, for want of a better word. And that's all the virus ever sees.
Well, what are still some mysteries about this virus and the coronaviruses in general?
Oh, there are so many mysteries. These are the viruses I've studied for 24 years now. Yeah, and it's nice to see some of the mysteries solved, but there are whole great big parts of this virus where we don't really understand why they're there. What exactly are they doing? You can knock them out and show that the virus is a little weaker, but that doesn't really tell you what they're there for. And in terms of the disease, we're starting to get a handle on how it happens. It's this thing called a cytokine storm, and it's basically an overreaction of one type of white blood cell called a macrophage. These guys they basically start screaming for help, calling for more macrophages to come in, and the rest of the body is saying, no, 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 no more macrophages. And so the disease is something like trying to drive down the highway with the pedal to the metal and the emergency brake on at the same time. It's just a disaster.
Have you been surprised by the reports of reinfection in places like South Korea, where somebody had it, then they tested negative, then allegedly they've been reinfected, and calling into question just how effective the antibodies that are developed after you have the virus are to preventing infection?
Oh, yeah. Okay, there's two parts of that one. One, we don't know that anybody's ever actually been reinfected.
Mm-hmm.
So in the early days, they were releasing people from hospital, and what we know now is that most of those people would still have some virus in them at the point when they are clinically recovered and feel like they're well enough to go home. And so what they're doing in China right now is a thing called a fecal test, because the virus is going to hang out in your intestines as long as it hangs out in any other part of the body. And so that's an easy place to sample, and as long as you're virus negative there for a couple of days, then we know you're safe to go home. But if there's still virus inside you, it can potentially flare back up. Now, on the antibody side, yes, we're getting in the first indications that some people, but not everybody, actually makes a strong immune response. Some people that have mild COVID-19 don't seem to make the right right kind of immune response that would protect them against reinfection. So I think it's very much a possibility. We just don't have a good documented case where this has happened for sure yet.
All right, my freshman biology teacher, Gary Goforth, is going to be so happy I had you on the show. He's very impressed. Benjamin Neuman, Professor Benjamin Neuman, he's the head of biology at Texas A&M University. Professor Neuman, thanks so much for joining us. Appreciate it.
Happy to help. Thanks for having me.
Thank you. And he joined us on our turnkey.pro answer line.
Connect with Dan and Amy on the AM 560 The Answer mobile app. Just text the word app to 64636 to download the app today.
Please listen. This is important. Anyone can be affected by the prescription opioid crisis. If you think you've been hurt by Purdue or its prescription opioids like OxyContin, you may be entitled to compensation as part of Purdue's bankruptcy, but you have to file a claim. Claims may include overdose, death, substance use disorder, lost wages, and neonatal abstinence syndrome. A confidential claim can be filed by individuals, a legal guardian, by survivors or relatives of people who have died or are disabled. The deadline to file a claim is June 30th, 2020, or you will lose your right to file a claim. For more information, visit PurduePharmaClaims.com, or you can call